to number 7 and use that kind of to start our discussion here of adding and subtracting functions, multiplying functions. Okay, this looks terribly complicated when it says find hg parentheses -5. I don't really like that notation, but what it means is there's a function h of x, okay, which is given right here. There's a function g of x, which is given right here. And you are evaluating them at -5, and then whatever the result is from each one, you're multiplying that together. So it's really as if I'm asking you to find h of -5, okay, which comes from h of x. So I'm putting -5 in wherever I see an x. That's -4. And then similarly, I'm finding g of 5. So g of x, which is x squared minus 6, g of -5, I keep saying 5, -5 squared minus 6, that's 19. I take those two results, -4 and 19, and I multiply them together and get my final answer here.
Okay.
Now, one thing I don't really understand with your book is why the domain, I don't know why they're restricting the domain. I mean, it doesn't affect this function, but it's kind of weird.
Yeah.
I don't really understand, but I mean, you are supposed to give a domain when you give a function, but I don't know why they would limit it to only negative integers here. But the point is this notation is, it looks more compact or more complicated than it actually is. Now, there is another way to do this, which I'd like to show you now. So notice we evaluated the function. What you could do is you could actually find the product of h of x and g of x. So we'll do that next. H of x is x plus 1. G of x is x squared minus 6. So if they want you to find h times g of x, and this is kind of better notation, what they mean is h of x times g of x. So you take that x plus 1, x squared minus 6, and you multiply them together, you FOIL. Okay, so you're gonna first times first, that's x cubed, outside minus 6x, inside is 1x squared, the last is minus 6.
Okay.
All right, now we cannot combine any like terms, but let me rewrite it here. It's usually good to put it in descending order, like that. So this is your new function. So now, and you can call it hg of x if you want. Now we can evaluate it at -5. So -5 cubed plus -5 squared minus 6 times -5 minus 6. And that should equal the same result as we had before if we did it correctly here. So -125 plus 25 plus 30 minus 6. So that's 55, and that looks like it is still -76. You can double check that if you want.
Okay. All right.
So what you should glean from this is there's a decision to be made, which is, do you evaluate the functions at the number and then multiply them together or add them together, whatever you're doing, whatever math operation you're doing, or do you combine the functions and then put the number in? Based on what you saw, what appears to be better? Faster? Which method is faster, or more efficient maybe?
I'd say probably the first one.
I would agree. Okay. But you should be able to do both. Okay.
Yeah.
Now, that choice only applies when it's asking you to evaluate, like they're asking in number 8. Number 8, they're asking you to find FG of -3. That means F times G at -3, which is really F of -3 times G of -3. Okay, do you want to do that for us? See what,
Sure.
get those individual values, multiply them together.
Okay.
I'm just going to step away for 30 seconds, be right back. All right, I'm back. Let me know if you have any questions.
Okay. I got an answer, but I don't think it's right.
Okay, let's do it. Let's work it out here together. So F of -3, I'll just come off to the side here instead. F of X is X plus 4. F of -3 means to put -3 in for X, which is +1. Do you have that?
Oh, okay, there we go. I actually did -3 -4. I was like, oh, that doesn't. So yeah. that's
G of
pretty
X,
simple.
similarly, you can find the value at. Then you take
Okay.
those two and you find the product of them.
Gotcha. So we -4.
Good. Okay, now let's do the full full F G of X here. Let's just do the product thing here. So that's F of X times G of X. That's X plus 4 times X minus 1. Okay. When you get caught up here, will you FOIL that for us, please?
Okay. Okay, I got X squared plus 3X minus 4.
Come on, say it with a little more certainty. X squared plus 3X minus 4. And then slam your
Yes,
fist
sir.
down.
Yep.
Okay. All right. Good. Now we're going to evaluate this at -3. Okay. And we should get the same result. Okay. This is not a proof, but this is like verifying that what you did works both ways, which is not a proof. My notation is so bad lately. All right. So that's -3 squared plus 3 times -3 minus 4. 9 minus 9 minus 4 is -4. So it does in fact confirm the other result.
All right.
So do you think that this always works?
Yes.
It does indeed work for multiplication. It also works for addition. Kind of multiplication and addition and multiplication are kind of the nice ones where things seem
Okay.
to like work out a lot of times. Subtraction is kind of like multiplications or addition, sorry. So it kind of is the same thing. Division's where you got to be really careful here. This is the exception. Okay.
All right.
So here's what you can do with two functions or two or more functions, but generally they're limited to two functions. You can add them, you can subtract them, you can multiply, and you can divide them. Okay, and we've focused today on this one, and I believe your book also focuses on addition and subtraction of them, but they give you kind of some examples there in class. So let's just look at a couple of those. I'll make some functions up here. Let's say f of x equals 1 minus x squared, and g of x equals 3 minus x. I want you to tell me f plus g. This is the notation of x, okay? This means, and I don't know why they write it this way. I don't know why they don't just write it as f of x plus g of x, but for whatever reason, math books like this notation on the left here. But it really means just to add the two functions together and combine like terms. Okay, so we're gonna take 1 minus x squared, and we're gonna add 3 minus x to it. Combine like terms, the 1 and the 3, maybe reorganize it so that it's in descending order. Something like that.
All right.
Okay. Now, let's say I wanted you to find f plus g of -1. Your options are, because now that you have it, is to go right here to the f of x plus g of x form, or you could put it in the original and add the two results together.
Gotcha.
Your choice. Keep in mind, I already did this, so this is probably better to put it in this one. But if we hadn't done that, you would want to do it that way.
Gotcha. All right. Very well.
So go ahead and give me that number here whenever you got it.
Okay. Uh, 0, 4. So f of x would equals 0, and then g of x would equal 4.
Okay. So you do them kind of separately and then add them together.
So 4.
Yes.
Gotcha.
Okay. Or you could go right to this one on the right here, minus a -1 squared minus a -1 plus 4. -1 plus 1 plus 4 is 4. Same thing. All right. So you're having a family dinner, right? And I always make this analogy. Yeah. Have you ever met someone with a food allergy?
Yes.
Maybe you have one. Okay.
No, I don't. But my
Okay.
cousins do.
But you've met people with food allergies, and like, what's the problem when you get together with a food allergy?
You gotta eat, quite frankly, low quality gluten-free bread. No, just kidding. You gotta have two separate things, or y'all gotta eat the substitute food, etc.
Right. Let's just say for a moment we're all gonna eat from the same dish. So if there's a food allergy, that dish cannot contain it. Okay. All right. So functions are kind of like food allergies with regard to their domain. Okay. So you and I are like this function right here. We're like 1 minus x squared. I think that's what I wrote here. We don't have any restrictions, right? But this function over here on the right, this one does have a restriction. What's the problem with this one on the right here? What's the first math commandment? Thou shall not
murder. No,
divide by 0.
Yes.
Do you see how this one's problematic here?
Yeah.
Okay.
X could equal 0.
You can't have 0. So I think it's a reasonable analogy here is that this is kind of like someone's got a gluten allergy, right? But you and I, a lot of people, we don't have any, or we're okay, right? But when we add them together, what happens here?
It does not equal 0.
Well, right, forget about that. Just look at the new function here. Does the new function have any restrictions?
No.
Yes. Right over here.
Yeah, right.
Okay. So it's like, hey, we come to the table here. We're up, you and I are f of x, we're happy. You got a family member with an allergy. They're 1 over x. Okay. And you cannot divide by 0. So this new function has a problem at 0, even though the old one did not. Right.
Gotcha. So we all suffer.
That's okay. You can draw, that's the different class altogether. But the point here is that you have to now look at your new function and decide, are there any restrictions? Okay. Now so is that okay? Is that clear?
Yes.
Okay. Now, Another thing that could happen here, and this almost only always happens, this only really happens with division, okay? And the food, the food allergy thing we'll just set for aside for the moment. Let's say f of x is 1 plus 2x and g of x is 3 minus 4x. If we add the two functions here or subtract, okay, there's no problems. You get at 1 plus 2x plus 3 minus 4x. You get some x's and you get some numbers, okay, whatever that is. But now with division, let's say we want f of x over g of x. What's the problem now?
It could equal 0.
Thou shalt not divide by 0, right?
Yeah.
Okay. And that's a problem, right? But so, that's where my analogy falls apart a little bit here, but it's like, just because they're both okay, doesn't mean when you combine them that they're not both okay. Okay. And yeah, you see that a little bit in certain scenarios, people don't mix well together. That family's fine on their own, that family's fine on their own, you get together and it's like, could be some issues. So your book does not focus on division in this section, so I'm not going to spend any more words on this. I think this would be a good point to transition to either advanced polynomial division, lesson 103, or do some problems like we usually do to help you work through this assignment. Your choice. What would you like to do with the rest of the time we've got? I was 30 minutes here. So what do you think would be the best use of our time today?
Maybe working on some of the problems since
okay.
Yeah.
So I see a number of these that we've kind of looked at over, our time together. Problems that stand out to me would be like 9, 10, 15, maybe 14. 18 was from last week. 24, 29, and maybe 30. I hadn't really looked at 30, but
yeah.
So that's kind of where I would say, but you are the customer. You dictate what we work on today. You tell me. I mean, we've done some word problems too in the past. What do you think here? Where are you kind
of? Anything that you think I need help on, that's what would be most helpful.
All right. I will. I mean, we did problems like 34. I remember in 92. I remember us even talking about those. Do you? Let's go to 15. I know 15's been an issue, so we'll just start there.
All right. Very well. Thank you.
All right. So 3 equations, 3 unknowns. What you look for is like something that will combine. You're trying to combine either equation 1 and equation 2, 2 and 3, or 1 and 3. And that's how your focus has to be. You kind of got to, almost draw rectangles there. Move your rectangle down. All right, well, those, and then the last one, maybe make 2 rectangles. Does anything stand out to you when you do that?
Probably the first 2 would be the easiest.
Yep. So what do you see when you look at the first 2 there?
X and Y we can add together.
Okay, so you get 2x plus 2y and the z falls out. That's good.
Yep.
So I agree.
And
that's good. 2x plus 2y gets 8. So how about 2 and 3? What do you see when you look at 2 and 3?
Well, if we add them, we just have 3x equals 3. So
I like that one. Yeah.
Yeah. So okay. X equals 1.
Yeah. So x is 1. Now, you might need to show a little work there, but now that you have x is 1, you go to kind of your second equation. I'm sorry, second option, which was 2x plus 2y equals 8. So you didn't lose anything by trying it. Sometimes we think, oh, if it doesn't work out, I wish I hadn't done that. Like, no, you gained something. You know that if you put 1 back in there, y is the only unknown. Yeah. Can you use that to solve for y, please?
Okay. Y equals 3.
Okay. And then you have your choice now, equation 1, 2, and 3. I'd like equation 1.
Mhm.
Once you solve for z in that one,
Z equals 4.
z equals 4. Now, if you wanted to be that, A plus all-star, top of your class student, you would probably check these in the other equations. That would verify it for sure. But what you did was sound. So it's up to you
Mhm.
if you do that or not. I would think you got it. So
Yeah.
all right, let's look at number 18.
All right. In other words, the 1/8 of the way from 1/5 to 2/3.
Okay, so you got to find the distance between those 2 points. Can you do that for us?
I think so, but I'll let you know if I need help. I have been kind of confused with these a little bit as of late.
The distance is literally right minus left. You're just subtracting the two numbers.
Okay, and then I'm gonna multiply it by 1/8, right?
Well, hang on. Give me your difference there.
32 divided by 15.
Yes, and you need to find 1/8 of in math means multiply. So
Mhm.
that works out nicely in terms of cancellation with the numerator.
So that's 4/15.
Okay, so that's the 1/8 of the way. What it's really asking though, it says find the number. It's really saying like assume your boundary, your start point is 0, and here's here's 1/5 and here's 2 1/3, not to scale. You need that new point. So you have to add it to the
Gotcha. 1/5. So that will be 9/15.
yes.
Okay.
No,
Gotcha.
wait,
Gotcha.
hang on. No, this is 3/15
Oh,
plus 4/15 is
right,
7/15.
okay, sorry. Yeah, very well.
All right. So I'm kind of thinking let's go back and look at like a 9 completing the square type
Okay.
problem.
Yeah, sure.
Uh, all right. So completing the square as an aid in graphing. What's interesting is they don't actually say what to do here. I think that like they want you to graph this, but they don't say to graph
Yeah.
and use completing the square to graph or something.
Yeah, it's a little bit confusing.
All right, start by setting it equal to 0. You want to move this 2 to the other side. So it's x squared plus 4x equals -2. This was a nice one, meaning that there's no fractions, there's no negatives, there's nothing weird going on. Do you feel comfortable trying to proceed from here or not?
Yes, I do.
Okay. What I'd like you to do is complete the square on the left, but then whatever this comes on the right, move it back because we're going to put it into vertex form.
Okay. 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 X plus 2. Well, like all those. Okay, so again, x plus 2 in parentheses, then squared equals 2.
Okay, so when you bring it over, it's -2.
Yep,
And
minus
that's when you
2.
bring this y back down. What is the vertex of this parabola based on this vertex form?
Oh, let's see. I remember going over that lesson. I was a little bit confused.
So
Honestly, that would have been a good day to have your help.
sorry.
No worries. I understand. I was pretty busy too, so it actually ended up working out pretty well.
Well, there's more to it. I didn't even have to. It ended up working out where there's if you knew my scheduling situation, it's a real chaotic situation. But
I can believe that.
I
Yep.
appreciate you being on time and really ready to go. So in terms of the vertex here, let me, and you can always say, hey, Matthew, like, I just don't know because I haven't seen this or it's been a while.
Mhm.
The vertex is H comma K. Most students say, okay, K, I get K. K is the number outside there. So let's do that one. That first. The one that we got is right there. H though, H is not this number. It's the wrong sign here because if it were this number, then the signs would line up as well. So most students remember it's the opposite sign as in here.
Okay.
I prefer looking at it as the number that makes this inside part equal to 0, which is -2, which is consistent with changing the sign of this. But I don't like rules like that because then it's like, when do I change the sign? When do I not change the sign? It is literally a number that makes the inside part equal to 0, which is -2. Your choice how you remember that.
Mhm.
A little more information here. If A is greater than 0, it opens up. And therefore, when it opens up, it has a minimum. If A is less than 0, it opens down. And therefore, it has a maximum. Okay. What is the value of A in this equation? What's not written here?
+1.
+1. So this one opens up, has a minimum. I don't know how accurate your sketches have to be.
Yeah, just
Like,
good enough.
sorry, -2 is here. I mean, this is pretty crude,
Mhm.
but that could be good. Or if you want to be really accurate, you got to actually probably make a table. What do you normally have to do here with these?
Yeah, just something like you did there is fine enough.
Okay. All right, so we'll do number 10 together. The ones with the negatives tend to be more chaotic.
Yeah.
Any questions on that though before we move on?
No, I think that was very helpful. I was kind of thinking that day, like, oh man, I'm so confused. So
It is a little unclear.
yeah.
All right, so completing the square here. One of the differences in the way that I show it that maybe you might see in other places is that I'm consistent and I'm always moving this number over, always moving it over no matter what. I don't use any formulas. I don't find that that's as helpful as sort of understanding this process where every line really is the same. Every line is consistently the same. This one, you have to factor out a -1. And it means you're factoring it out from something here that we don't know yet, which could be uncomfortable, but we don't know what it is yet. We'll figure it out. All right. In terms of like our boxes here, these numbers are still the same, but the number down below here is not the same as this red box. You'll see that in a moment here. All right, so if we just focus on what's inside parentheses, the x squared plus 4x, that becomes x plus 2 squared. And that's really similar to what we did in the last problem. So what goes up here is +4. Okay,
Yeah.
+4. But now notice if to get back to the previous line to figure out what goes in this box, you're multiplying everything by a negative.
So that'll be -4.
And to be fair, goes over there as well.
Okay.
Now, a few things here, like, and I'm very bad and negligent here. Sometimes I don't remember to write these things. You got to bring that -1 down. You got to remember to combine the two numbers on the right. And then because we wanted it in vertex form, because we're not solving, if you were solving, you'd keep going here. The way it is, you need to bring that number back. You have to add 2 to both sides. So it's -x plus 2 squared plus 2. Bring that y down. And now you have it.
All right.
Is that clear?
Yes.
So really only one extra line here that's different, this factoring out, but it does change the numbers. Like what a lot of students try to remember is this is always positive, and it is in like 80% of the cases. But you don't want to remember it that way. You want to remember that every line we have written here is the same. It's totally consistent, meaning they all
All right.
equal each other if you were to work them out.
Mm-hmm.
Okay, let me write the vertex form below here. All right, what is the vertex of your problem here?
Oh, okay, so H is going to equal 2.
H is 2, H is -2.
Right. Sorry. Oh yeah, and then T will, or I think that, no, that's a case, sorry. Same thing, -2.
It's the same number. These match. This one's opposite in sign in here.
Gotcha. Okay. I was kind of confused if that was a T or.
We'll do a couple problems here in a moment that are to get you back on track with vertex.
Right.
And I won't handwrite them. I'll find them in some books here. Okay, so the vertex is -2, 2. Does this open up or down, and how do you know?
It'll open down because the A is negative.
Less than 0, negative, good. So our crude sketch here of it, -2, 2 is right there. It opens down. You say that's good enough. I'll
Yes.
go with it.
Indeed. All right. That's good. Yeah, those were probably going to be the most difficult problems of the problem set. So we got that figured out.
All right, let me see if I can find some problems here for you to give me vertex of. I've got some here. They're handwritten, so you won't have any. I'm sorry, they're electronically done. So let's go. Start with number 5 here. Can you give me the vertex for number 5?
Okay. -1, -7.
So this one is 7, 1, 7, -1.
7.
Okay.
Oh, okay. I see. Good spots. Gotcha.
All right, so I'm going to give you the next one here, -2, -5. I'll give you the next one here. It's 3, 0.
Mm-hmm.
And the last one here is 2, 4. I want you to look at those and somehow make up in your mind how you're going to remember those. And I'm going to look for some more problems to give you.
Okay.
You got it?
Mm-hmm. Yeah, I think so.
Okay. All right, we're going to clear the screen here. Okay, what do you see here for vertex?
All right. So it's going to be -4, 2.
Let's go back and look. The order matters. H comes before K.
Okay, gotcha. So 2, -4.
Yes, 2, -4. And
Okay.
what about the other one?
The next one will be 1, 4.
1, 4. Good. All right, give me 30 seconds here. Do something. Okay. Let's go something else here. All right, a couple more here for you to look at. Give me the vertex, please.
2, 3.
Okay, good. The other one?
2, -2.
Nope. Try again. Here's what you said. I don't know if but that is not right.
Okay.
Why was the first one 2 on the left here?
It's the opposite of, like, it's the opposite sign from whiz.
Yes.
Oh, right. Okay, so that's gonna be -2, -2.
So here's another path to maybe helping you figure this out here is the transformations. So do you remember whether this is left or right, the transformation x minus 2 squared?
It'll be left.
Right 2, sorry.
Oh,
And that's consistent with this 2 here.
okay.
And this
Oh,
other one is
I
left
see.
2. And that's another way to sort of look at these. And
All right.
we got to get you to do a couple correct here. Sorry, so let's do 2 more, and then we'll jump to some more problems that you've got.
All right, very well.
All right, give me the vertex, please.
Okay. 2, -2.
Okay.
All right. 1, -3.
All right, very good. Okay, a couple of directions we could go from here. 24, 29, problems like 1, 2. Any of those stand out to you?
29, I think I got, but any of those others sound good.
I'm sorry, which ones? I didn't quite follow.
29, I think I
29.
got, but any of
Okay.
the others I can do.
Oh. All right, so 24 then would be okay?
Sure.
All right. So there are many other forms that you will see in math. X, Y is the Cartesian. This is polar. There's parametric. There's spherical. There's cylindrical, among others. And some of these work like, and there's certain problems that we have where they just work out better in these other forms that are in real life. So that's why you're kind of getting this. It's like just to expose you to, okay, these things are potentially important here. So for you in this problem here, you're going 4 right, and then 10 up. So not to scale here. Actually, maybe I can do it this way. 2, 4, 5, 2, 4, 6, 8, 10. All right, there we go. So better to break this into its XY components 4 and 10.
Mhm.
The radius is the square root of x squared plus y squared.
All right.
Could you calculate that for us, please?
Yes.
How's your new iPad working out for doing math and such?
Yeah, it's very handy, especially with aviation. We use an app called ForeFlight, which allows us to see the weather and stuff, and it's very handy.
Cool.
I look at that every morning.
Nice.
Indeed. All right, let's see here. Plus. All right. The square root of 116.
Okay. And if we're reducing that by hand, it would be 2 and 58, 2 and 29, which becomes 2 square root 29.
Mm-hmm. Okay.
And if we're going right to a calculator, it would be 10.77. So
Yeah.
not sure what you guys want there. The angle's always made with the x-axis. So theta is always with the x-axis. So if you were to give me this other angle up here, that would not be right because you want the one with the x-axis. So that is the arctangent of y over x. This one is probably right to the calculator. I mean, you can just write arctangent of 10 over 4, but that doesn't mean much to most people because they don't have a reference for like, where is that?
Gotcha. Okay.
Okay, what do you got there?
68.12.
Okay, so maybe 2 degrees. Does that look about right in terms of like, is it,
Yeah,
and it's
roughly.
not off, it's not terribly off in terms of,
Yeah,
on this pad I've got.
yeah, definitely.
Okay, so the way you present your answer, it's r comma theta. So you want to present it in that format, 10.77 comma 68.2 degrees. If you don't put the degree symbol, someone might think you mean radians.
Mhm. Gotcha. Okay.
All right. So I'm happy to go to 1 or 2, but sure there's nothing you want us to do?
No,
Okay.
whatever you think.
All right. All right, Sarah had a 40-mile head start and was driving north at 46 miles per hour when James and Renee began their pursuit at 50 miles per hour. How much farther did Sarah go before James and Renee caught up? So the scenario here is, here's J and R, and there's a 40-mile head start here. And their velocity. So generally you draw velocities as arrows. This is 46 mph. This is 50 mph. And we want to know when they get caught up, so that we can figure out how far the two of them are when they meet. Is that kind of clear?
Yes.
So we do D equals RT for both. So for the first person, Sarah, S, her distance is unknown. Her rate is 46. Her time is unknown. Now you have to decide here, are we going to talk about distance being relative to this starting point? And I think we should. Okay. But that's up to you. So what that does here is this distance here, it's really now D plus 40 because she got a 40-mile head start.
Mhm.
Then J and R, still D equals RT. Okay. Their distance is truly the distance, which is this long distance here is D. Their rate is 50 T.
Mhm. Yeah, this is interest. Yeah, we would usually use a slightly different formatting, but
I know.
works.
And I want to cut that out. I want to simplify that for you here. It's truly
Yeah.
just a D equals RT problem here.
All right.
And we in principle can solve this because we've got two variables, okay, and two
Mhm.
equations. So to do that, we'll combine them. That's typically the approach here. 50T plus 40 equals 46T, okay. Sorry,
Okay.
this is wrong sign here. This should be minus 40
Uh,
because they've already gone the 40. Sorry, that's a big mistake there. Okay, so you subtract 46T from both sides and you get 4T equals 40, so T equals 10 hours.
mhm.
Now, could we have figured that out from just looking at 46 mph and 50 mph, that it's a 4 mile per hour difference?
Uh,
Like they're going 4 miles per hour different. And that means that if they're 40 miles apart to start, it's 10 hours to get caught up.
mhm.
Sometimes you can get that from the information there.
Yeah.
All
Okay.
right. So we know in 10 hours they get caught up. So in 10 hours, the distance that J and R is 50 times 10, that's 500. Okay. And 46 times 10 is 460. So if we were to just kind of put that information back in our drawing over here, the whole distance is 500. And Sarah goes 460 before they get caught up,
Yeah, gotcha.
and everything kind of matches up there.
Yep, makes sense.
Yeah. I know that's probably different than what you see in the classroom or in your videos, but it's really these are all D equals RT problems.
Yeah, that makes sense.
All right, so we are basically out of time for today.